All right, just ignore my trippy background for a second because I know that it's probably a little bit weird to watch this repeat over and over itself a whole bunch of times. It gives a weird effect, but that's what happens when you record your recording software. Um, what I would like to do is to talk about the other activity that you're doing, which I've put up in the OneNote under the content library under the data and stats tab. I can also push this out to you individually if you would like to work on it there. Now, the idea behind this, let me go to a new page just for a second. Is we're talking about we're talking about a couple different things, but the key things that we're talking about are we have the difference between population, so pop, and I realise my writing with the trackpad is no good. The difference between the population and the difference between a sample. Right, that's the key bit of information that I want to talk about. Right, and I apologise that you have to look at my horrible trackpad writing. Right, it doesn't actually help explain it much better, but the difference between a population and a sample. Now, a population, as probably what you are used to thinking about, is let's say I have a large number of people. So let's say in this case, my population is this big circle, and this is all of MacKillop, right? So I'm just going to write Mac, mostly because it is kind of hideous to watch me write any more than that. Although I think it's cool that my document just tried to read what I was writing, thinks it says Mr. Mac, but that's okay. All right, so my blue squiggle is Mac, which is MacKillop. And these are all of my students in MacKillop. So, you know, each one of you can be a dot in here. And let's pretend that I've filled up this whole thing with plenty of dots and I'm not drawing lines in there randomly. Right? Each dot in there is a student. So all of MacKillop is the whole population in this example. And I want to take a sample, which is just a small slice of that group, to interview. Right? Because I can't interview everyone. So let's say I just take these, say 20. This is what is called a sample, right? So in this case, a sample may be a randomly chosen group of students to fill in a survey. So that's my sample, right? So it might be just some random students, I guess. So that's the difference between a population and a sample, right? One of them is the entire body that you are referring to. So let's say I'm interviewing students about MacKillop. The population is all the students at MacKillop, but I don't have time to interview every student at MacKillop. So instead, I take a sample of students at MacKillop, I survey them, and that gives me an indication of what the population might think. It's not 100% accurate, but it is the best solution that we have, right? And there's a whole bunch of mathematics that dedicate itself to how well a population, their opinions are predicted by samples. You might see, for example, on the news, there are things like they have the two-party political swing, right? On the news, they talk about which party Australia likes more at the moment. And you may think, oh, well, I'm sure that my parents didn't answer this survey. How is this being represented? Well, the answer is that they sampled part of the population and have used that to predict what the greater, the greater population of Australia may think. So let's have a look at some word problem cards. And I'm going to do the first one with you and try and link it there so you can get an idea of how this is done. I will apologise because there is actually a slight mistake here. This is supposed to be 35, not 25, but that's okay. And basically what you're doing is you need to read the card and then go to the next section and match it with a card that represents the population and then a card that represents the sample. And then lastly, we have to think from that data, what is being suggested, okay? So let's read 1A. It says, the following data has been collected from a random sample of high school students, grades 9 to 12. The data collected is referencing their interest in adding new sports equipment to the athletics department. Of the 2,700 students in the high school, 2 random samples of 100 students were surveyed, and this is what the result was. So, sample 1, 65 said bowling, 35 said tennis of the total 100. And in the second sample, 40 said bowling, 60 said tennis of the 100. So let's go down and see if we can find, in step 2, let's see if we can find a population card that matches 1A. Alright, so let's have a look. Our population in this case it is referring to a high school with students aged 9 to 12. There are 2,700 students in this high school. That gives us an indication of what our population is. There's 2,700 students at a high school in grades 9 to 12. So let's see if there's an answer that looks like that. 2,700 middle school students. That's an American phraseology, but essentially middle school is what you are in now, which is 7 to 9. So, I think it may actually be lower than that, but maybe sort of like 5 to 9. But anyway, so that's middle school. So it's not 2A. 200 students that do not have pets. That's not it. So we're looking for 2,700 high school students. So it's not 2C. 2D, that's another middle school, so it's not them. The first 100 boys and girls that attend lunch, that's not them. We've got elementary students. 1,200 high school students. Remember, we had 2,700. 200 students that do not own pets, that's not correct either. Carson elementary school students, that's wrong. Here we go. So 2J matches our population. High school students in the grades 9 to 12. We were looking, you could make the argument that you should include the number there, the 2,700, but this is the card that best fits our example here. So I'm going to put that in green, 1A. I'm just going to link it to 1A. Right, and that's how I know that that is the population for this one here. Now we need to look at the sample. Let's do that. So the sample says there were random samples of 100 students, or 2 random samples of 100 students, meaning there were 200 students who were sampled at random. Let's see if we can find a card that suits that. What do we got here? We've got 200 students that do not have pets. That doesn't make sense. So I think 3C is probably the best answer there. 200 students randomly selected, but I'll make sure there's nothing about 2 groups of students, which I don't think they are. So in this case, our sample could be the 200 students selected at random. So I'm going to put that in as 1A under the assumption that is the way that they were selected at random. All right. Cool. So that's the first thing, and then so we got our population and our sample. Now we've got to figure out, what does this data tell us? Well, it tells us that of the students surveyed, 105 prefer bowling, 95 prefer tennis. So bowling slightly edges out tennis as a sport, but they're both acceptable options. Let's see what our last step is. The inference is what is essentially implied by the data that we collected. So that's about pets. So it's got nothing to do with them, nothing to do with pets. Tennis would be a good option to add for boys and girls. Okay. Didn't mention anything about their gender, so I think that I guess that's just something to consider. Bowling would be a good sport to add for boys and girls. Tennis would be a leading sport to add to the athletics carnival. Bowling would be a leading sport to add to that. So I think this one here, 4H, best suits our answer, because bowling had more votes than tennis. So we're going to say that 1A relates to this card here. Right, 1A. With my beautiful writing. Right. So I've gone through and I've figured out this is card 1A. What is the population? What is the sample? And what is the inference? Now I want you to try and do the same with 1B, C, D, E, and F. Give it a go. See if you can figure it out for yourself as a bit of a challenge. All right. Thanks, everyone. Have a nice day. Bye.